Hi everyone, welcome to this lecture. So this lecture is our continuation of our project 1 where we are going to implement simple linear regression. So till now what we have done, we have read the data set and we have plot the scatter plot of the data set. So this is the scatter plot where we saw that there is a linear relationship between the independent data and the dependent data. So student, in this project 1, basically we are going to do two very important things. So basically we are going to implement simple linear regression in two different ways. First, we will implement simple linear regression manually, and then we will use important Python library using scikit-learn to implement simple linear regression. But first, we will implement simple linear regression manually using a least square method. So we know that the least square method has this equation: x transpose x, then inverse, then x transpose y times y. So this is the equation for a least square method. So in order to apply least square method, we need to construct three matrices. That is, we need to construct y matrix, which is the matrix of target variable. We need to construct x matrix, which is the matrix of feature. And then we need to construct the weight matrix. Now, since we are going to implement simple linear regression, in simple linear regression, we have only one feature. Therefore, we have only one weight, and we also have to calculate the value of a bias. We also know that in order to multiply x and w, in order to multiply these two matrices, we need to append one at the column of, or at the first column of a feature matrix, so that the size should be compatible for matrix multiplication. So if we see in the previous lecture, we have already extracted feature, that is x, and we have already extracted y, that is target. Now it's time to append one. So in order to append one, first we have to create ones. So we will use numpy function in order to create ones, np.ones, and the size of ones is equals to the length of x. Let's run this cell and to see the ones. So we can see that we have created the ones in a column fashion. So now we have to append this one to the x. So in order to do this, first we have to reshape x. We have to reshape x so that x should also be in the form of column. So we are reshaping x. So this is the value of x. This is ones and this is value of x. Now it's time to append one into the x. So here we are using np.concatenate, and we are appending, or we are concatenating ones, and we are concatenating ones to our matrix x, and we are doing it along the column wise, that is axis is equals to 1. And we call the variable at xls, that is the value of x according to least square method. So let's run this cell, and let's run this cell to see our x. Now we can see that this x is according to the least square method. We have appended the 1 here, and we have the features in our second column. Now we can also reshape y to transform it into a column wise. Now we have x, now we have y. Now it's time to apply a least square method. If we see the equation of a least square method, so the first step is to take the transpose. Then the second step is to multiply x transpose with the x. The third step is to take the inverse. And then fourth step is to multiply x transpose with 5. And the final step is to multiply this whole matrix with this whole matrix. Let's do it by step. We have also learned this in our theory lecture where we solve a numerical example on least square. Now we are implementing this in Python. So the first step is to take the transpose. For transpose, we are using np.transpose function. That is, we are using transpose function from a numpy. So we are transposing our x matrix, and we are calling this into xt, that is x transpose. Let's run this cell. The second step is to multiply x transpose with x. So here we are using np.matmul. So matmul is the short form of matrix multiplication. So we are using np.matmul, and here we are multiplying xt with the original x. That is the least square x, where we have appended 1 in the first column. The next step is to calculate the inverse of xt multiply by x. So we use numpy again. This is lin algebra dot inverse. So basically we are using linear algebra function inside a numpy, and inside linear algebra, we are using the inverse function. So here we have the product x, which is obtained by multiplying the transpose of x with the x. Now we are taking the inverse of this product x, and we will call it inverse underscore x. So we have taken the inverse. The next step is to calculate x transpose y, that is to multiply x transpose with our y matrix. So again, we are using np.matmul, which is a short form of matrix multiplication. The last step is to calculate our weight matrix using a least square method. For this, we have to multiply this inverse matrix and this xty. So let's run this cell and let's observe the value of our weight matrix. So we can see that this is the value of a bias and this is the value of the weight associated with the feature. Since we have only one feature in our simple linear regression, therefore we have only one weight. So if we want to see these values separately, so this is our bias. We have reduced it to 2 decimal places, and similarly we can see our weight by using the command round to. So here we have eliminated all the long values after the decimal, and we have transformed our value to 2 places of decimal. So in this way, in these simple 5 steps, we can see that we have manually applied least square method, and applying by least square method, we are able to find the optimal values of the bias and the optimal value of the weight. Now it's time to interpret the concept of a weight. So the value of weight is 9449, 9449. It means our dependent variable will increase by this value if the value of independent variable increase by 1 unit. So if I increase the value of independent variable by 1 unit, suppose its value is 1.1 and I will change it into 2.1. So if I just increase the value of my independent variable, which is my feature, by a 1 unit or by a 1 value, it has the effect on dependent variable that the dependent variable will be increased by this value. So weight is the quantity which establishes the linear relationship between the independent variable and the dependent variable. This is what we learn in the definition of a linear regression. So here the linear relation has been established, and this relation is established by a weight. So this value of weight is saying that if we increase the value of the independent variable by 1 unit only, then the dependent variable will be increased by 9449.96. Here I am putting a dollar, so I have to remove this. This is a typo. The reason is that there is no unit associated with our dependent variable. So our dependent variable will increase by 9449.96 if the value of independent variable increases by 1 unit. So we have doing our project 1, we have implemented manually simple linear regression using least square method. We see that how to calculate the optimal values of a weight and how to calculate the optimal values of a bias using least square method. So I stop this lecture here and I will continue my project 1 in the next lecture. See you there.